The power grid goes down. Everything around you stops working. Your phone is a paperweight. Your refrigerator is silent. Your car won't start because its computer brain is fried. But somewhere in a barn, a workshop, or a forgotten corner of a basement, there are machines built 50, 70, maybe 100 years ago that will keep running. Machines that don't need electricity. Machines that don't need circuit boards or microchips. Machines that were designed when the world understood that complexity is vulnerability. In the next 10 minutes, you're going to learn how to identify these machines, how to revive them, and why they might be the difference between survival and collapse when everything modern fails you. Modern machines are dependent. They rely on constant electrical current, sensors, computers, and digital systems that are fragile by design. When the power goes out or an electromagnetic pulse fries every circuit for hundreds of miles, these machines become useless metal and plastic. They were built for a world where power is always available. That world is not guaranteed. Older machines were built on mechanical principles: gears, levers, springs, and momentum. These are physical systems that operate based on physics, not electricity. A hand-crank grain mill doesn't care if the power is out. A treadle-powered lathe doesn't need a wall outlet. A mechanical water pump powered by a windmill or a hand lever will move water without asking for a single volt. These machines were designed during an era when electricity was new, expensive, or unavailable. They were built to work, regardless of infrastructure. Understanding this difference is critical. It's not nostalgia, it's engineering reality. Mechanical systems fail only when their physical components break. Electronic systems fail when power is interrupted, when chips burn out, when software corrupts. In a long-term grid-down scenario, you need tools that answer only to physics. Before we go further, I want you to know that we've put together something for people serious about preparing for the worst. Check the link in the description for our ebook. It's a Gamma Roach comic book that walks through survival scenarios and the mindset you need when civilization stops holding your hand. It's built for people who think about these things. Also in that description, you'll find our merch. It's gear designed for the survival-minded community. People who understand that preparation isn't paranoia. Check it out, if that's you. Let's talk about what fails and what doesn't. Modern vehicles are rolling computers, fuel injection systems, electronic ignition, anti-lock brakes, engine management computers. All of it dies without power or when exposed to an EMP. But a vehicle built before the mid-1970s, especially one with a carburetor and mechanical ignition, can still run. It's simple. Fuel, air, compression, spark. No computer required. The same principle applies to nearly every category of tool and machine. Electric drills stop when the battery dies. A hand-crank drill keeps going as long as you can turn it. Electric water pumps need a grid or a generator. A pitcher pump or a ram pump uses gravity and mechanical advantage. Modern ovens are useless without electricity or gas pressure. A wood-burning stove with proper airflow will cook your food and heat your home for as long as you can feed it. The pattern is always the same. Dependence on external systems is a weakness. Self-contained mechanical operation is strength. When you're evaluating what belongs in your preparedness plan, ask yourself one question. If the power never comes back on, does this machine still function? The first mistake is assuming old means broken. People see a rusted hand pump or a dusty treadle sewing machine and think it's junk. Most of the time, these machines just need cleaning, lubrication, and minor repairs. They were built to last decades, sometimes generations. The engineering tolerances were tighter. The materials were heavier. They were designed to be repaired, not replaced. The second mistake is not testing before you need it. You cannot wait until the grid is down to figure out if your hand-crank grain mill actually works or if the seals on your manual water pump are rotted through. You need to use these tools now. Learn how they operate. Understand their quirks. Find out what breaks and fix it while you still have access to parts and expertise. The third mistake is ignoring maintenance. Mechanical systems still wear out. They need oil, grease, and occasional part replacement. A hand-crank tool that sits unused for years will seize up. Leather gaskets dry out, metal corrodes, wooden handles crack. You have to care for these machines or they'll fail you when it matters most. The fourth mistake is underestimating the physical effort required. These machines work without electricity because you are the power source, your muscles, your endurance. A treadle-powered machine means you're pumping your legs for as long as you need it running. A hand crank means your arms are doing the work. This is not a flaw. This is the trade-off. But you need to be realistic about your physical capability and train accordingly. If you're searching for machines that will survive a grid-down event, focus on simplicity and redundancy. You want tools with as few moving parts as possible. Complexity means more points of failure. A hand crank meat grinder with 3 main components is better than one with 15. Look for machines made before 1980, ideally before 1960. This is when most household and farm equipment was still being built with mechanical operation as the default. After that, manufacturers increasingly integrated electric motors and electronic controls because they were cheaper and easier to mass produce. Older equipment was built in an era when durability mattered more than cost. Cast iron and steel construction is a good sign. These materials last. They can be repaired with basic welding or machining. Plastics and composites cannot. If a part breaks on a modern machine, you're often looking at a proprietary replacement that might not even be manufactured anymore. If a cast iron gear breaks on a 1940s grain mill, a machinist can fabricate a new one. Pay attention to brand names that were known for quality. Companies like Fairbanks, Morse, Maytag, Singer, Lehman's, and John Deere built equipment that was meant to be passed down. These weren't disposable products, they were investments. When you find one, you're not just getting a tool. You're getting a piece of engineering from a time when things were built to outlast their owners. Reviving an old mechanical machine starts with assessment. You need to figure out what's broken, what's worn, and what's just dirty. Start by disassembling it as much as you're comfortable with. Take photos as you go so you can remember how it goes back together. Clean every part with appropriate solvents. For metal, use kerosene or mineral spirits. For wood, use a mild soap and water. Remove rust with a wire brush or sandpaper, but be careful not to damage machine surfaces. Once it's clean, inspect for cracks, breaks, or excessive wear. Castings can crack over time, gears can lose teeth, bearings can wear out. Some of these problems are fixable, some aren't. If a main structural component is cracked, that machine might not be worth saving unless you have access to welding equipment and the skill to use it properly. Lubrication is critical. Old machines were designed to be oiled regularly. Many of them have oil ports or grease fittings specifically for this purpose. Use the right lubricant. Light machine oil for fast-moving parts. Heavy grease for gears and bearings. Do not use modern synthetic oils unless you know they're compatible. Some old gaskets and seals were made from materials that break down when exposed to certain chemicals. Replace worn parts where necessary. Leather belts, gaskets, and washers dry out and crack. Rubber seals degrade. Springs lose tension. Wooden handles rot. Many of these parts can be fabricated or sourced from specialty suppliers. There are communities of people who restore old equipment, and they can often point you toward parts or fabrication services. Test the machine incrementally. Don't just put it back together and crank it at full speed. Operate it slowly at first. Listen for grinding, binding, or unusual noises. Watch for parts that aren't moving correctly. Make adjustments as needed. This is a process, not a one-time fix. Let's talk about what these machines actually do for you in a survival scenario. A hand-crank grain mill turns whole grains into flour. This means you can store wheat, corn, or oats for years and process them as needed. Whole grains last far longer than flour. This one machine extends your food security significantly. A treadle-powered sewing machine lets you repair clothing, make new garments, and work with heavy fabrics like canvas and leather. In a long-term collapse, clothing becomes a critical resource. You can't just go buy a new jacket. You need to repair what you have or make something from scratch. A manual water pump brings water up from a well without electricity. Water is survival, priority 1. If your well pump is electric and the grid is down, you have a serious problem. A pitcher pump or a hand-operated deep well pump solves that problem. You can also look into ram pumps, which use the energy of flowing water to pump water uphill. No external power needed. A wood-burning stove with mechanical draft controls gives you heat and cooking capability without gas or electricity. As long as you have access to wood, you have energy. This is renewable. This is local. This doesn't depend on supply chains or infrastructure. Hand-crank tools like drills, grinders, and sharpeners let you maintain and repair other equipment. You can sharpen knives and axes. You can drill holes for repairs. You can grind grain or meat. These are foundational capabilities that keep everything else running. Mechanical engines, particularly older diesel engines, can run without electronics. A pre-1980s diesel tractor or generator with a mechanical fuel injection system will keep operating as long as you have fuel. Some of these engines can even be converted to run on waste, vegetable oil, or biodiesel, giving you options when conventional fuel is unavailable. Here's what you need to understand. These machines are not magic. They will not solve every problem. They require skill, effort, and ongoing maintenance. If you've never operated a treadle sewing machine, you're going to struggle at first. If you've never hand-cranked a grain mill for 20 minutes straight, you're going to be exhausted. These are skills. You have to build them before you need them. Safety matters. Mechanical machines have exposed gears, belts, and moving parts. They can catch clothing, hair, and skin. Older equipment often lacks the safety guards that modern tools have. You need to pay attention. You need to operate them with respect. A moment of carelessness can cost you a finger or worse. Do not assume that just because something is old, it's safe. Cast iron can crack and shatter under stress. Belts can snap. Springs can release with enough force to cause injury. Inspect everything. Test everything. Treat these machines like the powerful tools they are. Also understand that some things simply cannot be done without electricity or fuel. You are not going to run a modern hospital on hand-crank power. You are not going to manufacture precision electronics in a grid-down scenario. What you can do is maintain basic survival functions: food processing, water access, clothing repair, shelter maintenance, and small-scale manufacturing. That's the realistic scope. Bringing dead machines back to life is not just about the machines. It's about you. It's about shifting your mindset from dependence to capability. Modern life has made us passive consumers. We don't fix things. We don't make things. We buy them, use them, and throw them away. That model only works when the systems behind it are functioning. When those systems fail, you need to become someone different. Someone who understands how things work. Someone who can look at a broken piece of equipment and figure out how to repair it. Someone who doesn't panic when the power goes out because you've already built redundancy into your life. This is not about going back to some romanticized past. It's about taking the best knowledge and tools from that past and integrating them into a prepared, resilient present. You can still use modern technology where it makes sense, but you need a fallback. You need tools that don't depend on systems you can't control. When the grid goes down and stays down, the world will divide into two groups. Those who are helpless because everything they depend on is dead, and those who are prepared because they built their lives around principles that don't require permission from the power company. Old machines are not antiques. They are lifelines. They are proof that humans survived and thrived long before electricity, and they can teach us how to do it again if we have to. Find these machines, learn them, restore them, use them. And when the day comes that everything modern stops working, you'll have tools that don't care. Tools that will keep running as long as you're willing to turn the crank, pump the handle, or feed the fire. That's the difference between preparation and hope. Hope is passive. Preparation is active. And in a world without power, action is survival.